Welcome all. In this video, we will present an auto gear transmission function implemented using Mamdani Fuzzy logic. This video is made as part of assignment 6 of nature-inspired computing course at IIT Gandhinagar. We have two inputs, the RPM of the engine and speed of the car, obtained from the sensors embedded in the car. The problem statement requires us to implement a Mamdani Fuzzy Inference System to determine the gear number that the car should be operated at. This is the schematic for the FIS, which is the Fuzzy Inference System. The crisp inputs are first fussified, their degree of membership is determined, and using the rules base, the fuzzy output is obtained. We have used center of mass to defussify the fuzzy output. Finally, the output is rounded off to the closest integer. There are 5 membership functions for the RPM input. The 5 functions correspond to the RPM range within which each of the 5 gears works most efficiently. The ranges for gears 2, 3 and 4 have a huge overlap, but this is what was obtained from the data for a car given in the link above. There are 5 triangular membership functions for the speed input too. Again, the 5 functions correspond to the range within which each of the 5 gears works most efficiently. Finally, we have another 5 triangular membership functions for the output gear number. We have 5 simple rules in the rules base. For each gear number X, if RPM is within gear X RPM range or speed is within gear X speed range, then output gear number is X. The advantage of using OR over AND may be demonstrated using the following example. Say we have input such that RPM is in gear A range but not in gear B range, and speed is in gear B range but not in gear A range. If we use rules like RPM has to be in gear A range and speed too has to be in gear A range, then for the present scenario, neither gear A nor gear B would have a non-zero degree of membership. Whereas if we use OR rules like once shown above, both A and B will have non-zero degree of membership, and the final output would be a weighted average of A and B. In real life too, during such a scenario, we would be confused whether to choose gear A or B. And this confusion is addressed by the Fuzzy Inference System using the OR rules. Here we have shown a scenario where each of the 5 gears is selected one by one. Gear 1, Gear 2, Gear 3, Gear 4 and finally Gear 5. This is the surface plot describing the gear number as a function of RPM and speed. In this video, we have demonstrated how varying the RPM and speed results in different gear numbers. The gear number to be selected is shown by the green lamp at the bottom center. That's all. Thanks and have a nice day.